Hello everyone, welcome to this video. This is lecture number 8. Already 7 lecture are covered to the classical mechanics mainly for semester 1 of BSc, and on the other examination also this is also important. In this video we want to discuss about the gravitation and Kepler's law, gravitational law and Kepler's law. This is the syllabus for the mechanics of semester 1 in mainly University of Calcutta. These portions are covered in the previous lecture, and in the last lecture we covered up from central force, reduction of two body, center force problem, one body, setting up the equation of motion in plane plot coordinate, differential equation of the path, motion and the inverse square. These part are covered in the last lecture. In this lecture we want to discuss the Newton's law of gravitation, inertia and gravitational mass, Kepler's law, stationary in circle, orbital and application, wireless. This portion we want to discuss in this video. Let's start with, and this will be covered up in the upcoming lecture. Okay, so let's start. Newton's law of gravitation, you know very well. If there is two masses, small m and capital M, situated at a distance r, then they are feel a attractive force which is g mm by r square r cap. Okay, this is along this path, this is along a radial, so this will be attractive, number one. Number two is inverse square law follow, and this will be central force because this is f of r cap, right? So when two mass or bodies situated at a certain distance, then they interact with each other in inverse square law. This is known as Newton's law of gravitation. This is the form of Newton's law of gravitation. This nature will be attractive in inverse square central force, right? Next we comes into the inertia and the gravitational mass. What do you mean by inertia mass and what do you mean by gravitational mass? When a body is in a rest, if we apply the force F, then the body, if this body comes into acceleration A, then we can write F equals to ma. This mass is the inertia mass because it's this mass helps to its inertia, that is the rest inertia. This is a two type of inertia, rest and motion. In this case this is a rest inertia, so to retain this rest inertia, this mass will help. So inertia mass measure object resistance to bring the accelerate to a force, so this mass resists to accelerate this body, so that's why this mass is known as the inertia mass. Another mass is the gravitational mass. When two bodies are separated at certain distance, they are attractive. So these mass which are used for the gravitational attraction, this mass is the gravitational mass. This is the basic difference between the inertia mass and the gravitational mass. This gravitational mass is two type: active gravitational mass and the passive gravitational mass. Active gravitational mass, for which there are field are generated, and passive mass which are placed in the field of another body, this is called the passive gravitational mass, and this is called the active gravitational mass. Experimentally we can see there is this gravitational mass and the inertia mass, both are the same value. So we can say this gravitational mass and the inertia mass value are the same, so there is no difference, but with the some basic definition there is difference, inertia mass and the gravitational mass into magnitude, but the magnitude is the same. Now comes into the Kepler's law of motion. There is three Kepler's law of motion: first, second, and third. First Kepler's law of motion says if a body, any stable planet in the solar system moves in a elliptical path, and one of these foci, in a elliptical path there is two foci, so one of these foci the sun will be present here, either air or air, and the planet moves in the elliptical path. Okay, if you attend the previous lecture, you know the energy will be negative in case of particle when the moves in the elliptical path. So that's why here the stable planet can be in the solar system, moves in elliptical orbit around the sun, and sun obey being at the foci, any of these foci this is present. If you wants to derive this first law of Kepler's, you can see this is the gravitational law, and for attractive this gives you negative, and we obtained previously in the previous lecture, that is the eccentricity with this, and this will be less than 1 when energy will be less than 0, right? So energy will be less than 0 and energy will be negative when the system will be stable. Since the planet moves in the stable configuration, so you can see energy is negative. Energy negative means epsilon is less than 1, which is says this path will be elliptical. So we can say this path will be elliptical when this will be stable obey the this gravitational force, right. Second law says the aerial velocity, if this is a planet moves in this elliptical path and this is a sun in the center, follow up the elliptical path and the radial, that is the planet to sun is radius vector, cover up this area, this is called this area per time is called the aerial velocity. This aerial velocity will be constant in this motion of this planet. When the planet move in this elliptical path, the aerial velocity will be conserved, right. So you can see here that they when this is far away from the sun, they move in this small p2q with this area. If you want to same area in that time, you need to go in the far length. This length will be compared to that length will be larger. So you can conclude here that the velocity when the planet is far is less compared to when is near. That's mean when the planet is near to the sun is move faster compared to when the planet is far is slower, right. So in another word, the second law says that the aerial velocity, that is dA dt, will be constant. If you want to prove this formula, you can say here this is a radial vector and this is the angle theta. This angle will be d theta. If you want to say this angle will be d theta, take this angle will be d theta. So you can say here this will be r d theta. So what is the value of this? If d theta is small, this can be taken as a triangle. So well, area of the triangle will be half into base into height. So r into this pq. This pq is r d theta. Now this is r square d theta and in velocity. If you did time divided by time, you will be get this the r square theta dot and theta dot r square theta will be h, which are previously in the previous lecture we cover, and you know h is the constant. So you can say this aerial velocity will be constant. And also we derive this expression, the law property of the central force is the aerial velocity also constant in case of central force. So that's why this is can be said the aerial velocity when the planet move in a elliptical path, the aerial velocity will be constant. Next, go through the third law, which says that the time period of the planet, when the planet moves in the elliptical path, there will be time period. Square of this time period is proportional to the semi major axis, q of the semi major axis. That is, this is the major axis, there will be 2a, semi major is the half of the major axis. So t square proportional to aq. That means square of the time period of the revolution of the planet is directly proportional to the q of the semi major axis of the elliptical path. That means when the planet moves in the elliptical path, the time period square of this time period is proportional to the q of the semi major axis. Okay. So if you want to derive this expression, you can say the time period will be the area of the elliptical. Actually, time period is the length by velocity, or you can say in the aerial term, so the area of the elliptic and the aerial velocity. So area of the ellipse is pi ab, A is the semi major axis and b is the semi minor axis, and area of this velocity, aerial velocity, we just derive this h by 2. Here we put h by 2, you will be get 2 pi ab by h. Now what is the value of ab and h? L is the semi-natural then L equal to b square by a. This is the formula of semi-natural, and the r is written here. This is was this formula was derived in the previous lecture. Just go through the previous lecture, description given in the link is given in the description box, you can watch. This formula will be get, just compared to the general formula of the conic. You can see this is the L, and so L will get this. So this you can find out the value of h. So just put the value of h and the value of b, where b is root over LA, you will be get this. So you can say the a square t square proportional to aq. This is the third law of Kepler's law, right. Now go to the into the general feature of a orbit. So you can say what is the general feature of the orbit. Inverse square force, this is the inverse square force in the form, and if you know the this is the force will be d minus dv dr. So v will be integration f of r dr. So if you put f of r, that is the k by r square dr. So you will be get this formula k by r plus c. So the r tends to infinity, so potential tends to zeros. That means c equals to 0. At r equals to infinity, potential will be 0, so you will get the constant equals to 0. So this is the form of the potential. But here the effective potential will be the two term, that is k by r term is present with the additional term, this term which already obtained in the previous lecture. You can see these two term are is the effective potential of this system. Okay, now we can discuss about the nature of the effective potential corresponding with the value of k. If you k greater than 0, so this will be positive and this is positive, so you can say there is no negative, no, this is square, and it is must always positive. So this term must be positive. When this is positive, k positive, so total term is positive, so this will be always positive. That's why this curve will be like that in case of k greater than equal to 0, and this is the positive force and this is the repulsive. Okay, in that case the potential card does not have a minimum value, in that case it does not. But in case of k negative, if k is negative, so this negative and this positive they are a combination, that's why this nature of card, this positive and negative per resultant, this is the resultant card. You can say here this is the two term, this is the positive term, this is the negative term, resultant will be like that. Okay, so some observation can be obtained from this curve. You can see here, that is in case of k greater than 0, there is always positive. So at a certain energy level, that is r0, you can say if a certain observation for total energy equals to E.O.M, there will be only terminate point that r equal to r0 where the insert of the curve, that means the energy value where the curve intersect, that is the r0. Okay, so in that case there is no stable position, that is the scattering. In the another form, that is k less than 0, there is 3 point we take, that is E1, E2, E3 and E4. In case of E1 there is one intersection, in case of E2 there is another intersection, in case of E3 there is two intersecting point, and in case of E4 there is one tangent point, right? So in that case this is positive and this is the scattering point, and this is the energy 0 and infinity at E2 is meet in 2 point. In case of E2, you can say this is the scattering point at E1. In case of scattering point, that is with r equals to r1, what is the r1? If this is a nucleus and this is the alpha particle, this comes into that path, so this is the closest distance, this is the r1. Okay, and when this will be 0, there is 2 point intersect at r equal to r1 prime and infinity, that is the particle goes to infinity but the radial velocity fall continuously. Next is E3, where there is two intersecting point, right? There is two intersecting points, so at these two position this energy will be follow up. So you can see here, this is the 2 point intersecting point, particle bound between these two turning points, that means the particle is oscillated in this way in that case. In the fourth case, that is when this tangent, that means this is the energy is minimum at that point, the energy will be minimum and the first derivative of this v effective will be 0. See, at r equal to r4, at r equals to r4, the minimum derivative will be 0. If you derivative, the value of r4 will be like that, which is just the centripetal force required to the obtain the circular path motion. Okay, now comes into the satellite in in the circular orbit and the application. Uh, if this is any planet and this is a satellite moves in with the distance r from the center, so you can see this is the gravitational force and this is the centripetal force. If it is two equal, then we will get the velocity of this satellite. Okay, if you want to find out the time period of the satellite, this is 2 pi r by v. So if you put the value of v, you will get this type of equation. And you wants to know the what is the work done, so work done will be like that, the work done will be 0 because this displacement along that, and the force will be, so this is the 90, so cos 90 is 0, that's why the work done due to this gravitation force is 0. So the kinetic energy change will be 0 because the work energy theorem says that work done is equals to the change in kinetic energy, so the change in kinetic energy also 0 in that case, right? Now you want to know the geostationary, the time period of the satellite will be given here. So if you change the radius, the time period will be changed. So with changing this radius, that is the distance between the satellite with the center of this planet, such that the actually we the planet here we discuss about the earth, that will That's why we take the time period 24 hours. So if the time period of satellite will be 24 hours and this rotate in the same axis with the rotation of the earth, so earth is rotated in 24 hours and the satellite also rotated in 24 hours. If there is any man below the satellite, if there is any man in below the satellite, you can see that the satellite is on its head, because the speed of this man and the satellite will be the same, just like a two parallel train with the same speed. You can see these are the stationary like that. Here these two are the two are follow up in the same speed. So this man see this satellite in the stationary. That's why it is called the geosynchronous or geostationary. Geostationary is satellite, and this orbit is known as the geosynchronous orbit. And there is another satellite. There is a satellite. The polar satellite moves in the perpendicular to the axis of this earth, and this time period also 24 hours, such that the earth rotate in this 24-hour total, and this also rotate in the total. That's why after rotating in one circle, the collect the all the uh, weather report of this earth. Okay, this is help is this and this is help us for the communication system. Next, go to the wireless. That means this is a this is earth, and this is a satellite which moves in this orbital, and the man on this satellite. Okay, the man weight feel wireless. Why? If you see about the mass of the satellite with this main m prime, so you can equate this weight, that is the m prime g prime. Here there will be g prime, will be this gravitational force, you will be get the g prime, that is the acceleration due to gravity at that point. And this gravitational force will be equal to the centripetal force, will be the velocity of this satellite. And after that, if you wants to know about the mg prime of this man, this will be r plus, because the reaction force, plus mv square by r, the centrifugal force. Here will be get the r will is the weight which will fill this man, right? So if you put this value of g prime and the value of v, will be get the same value, this will be give 0. That means the field reaction force feel by this man will be 0. That means when the man rotate in the orbital space, the weight will be 0. I think clear. If there is any doubt, you must comment in the comment box, or you can contact with me. And this is the next part we will want to discuss in gravitational potential energy, gravitational potential field, and due to spherical sphere. We want to discuss in the lecture, and the upcoming lecture will be cover up this portion also. So stay with this channel, and this is all about me, and this is my contact details. You can contact with me, and this is my YouTube channel details. Go to this channel, you will be get the all the videos which already uploaded, and share this video to your friends so that he or she also get benefit from this video. And subscribe this channel if you new in this channel, and this already subscribe, thanks for subscription. Press the bell icon to get the notification of upcoming video. So take care, we will meet in the next video as soon as possible. Thank you.